Let's look at problem number 4. Determine the force in member DG and FH of the truss shown. Okay, he wanted to use section AA. This is different than the joint. In the section, we could use moment. You could use forces at the X. You could use forces at the Y, summation equal to 0. So he wants this cut. So you're going to cut this truss like this. Okay, and he wanted to find out force DG, this force DG, and force FH. Okay, nice. Before you find this force and this force, let's find the force of the reaction N, and you can see that it is a ruler. So there is the reaction in the y-axis N, and A, you can see it's like a hinge. It's AX and AY. So let's find initially the reaction AX, AY, and N. So we should find, first of all, remember here, you take the whole truss. There's two forces here, one in the Y and one the X, and here one in the Y. So if you take moment at point A, you can see that this force is going up. This force here is going up. So a moment at this point gonna make this force push it counterclockwise times the perpendicular distance, which is what? So N times the perpendicular distance, which is 6, 6, 1, 2, 3, 4, 5, 6. So N times 36. So N times 36. So N times 36. And it seems to be that everything else is the negatives, which means it's going to be clockwise. Let's see. So moment at this point, this will push the whole truss clockwise. So 0.5 times 6, 0.6 times 12, 1 times 18, 0.6 times 24, and 0.5 times 1, 30. Okay, and we just account for this. So we do it like this. So 0.5 times 6, 0.6 times 12, 1 times 18, 0.6 times 24, and 0.5 times 30. So, and of course, everything else here, 36 times n, you could find the normal, you could find the n in the y-axis. N is equal to 1.6 kip. Now, this is summation of moment at A. Let's find summation of forces in the x-axis. Remember, this is going in the y, and AX, there is nothing else in this truss in the x-axis, so AX is equal to 0. So summation of force of X equal to 0. You find a summation of forces of X equal to 0, AX equal to 0. Now let's find summation of forces of the Y. Remember, we found NY. Now we need to find AY. Remember, 0.5 negative, 0.6 negative, 1 negative, 0.6 negative, 0.5 negative. You end up with what? AY plus N is equal to, of course, negative, so which means if you take it to the other side, it's going to be plus 0.5, 0.6, 1, 0.6, 0.5. AY plus N is equal to 3.2. And remember, N, we found it here, 1.6. So 1.6, take it up there, 3.2 minus 1.6, AY is equal to 1.6. Now we found the reaction. Let's take the cut. Remember, we found this reaction, we found this reaction. Now we're going to do it a cut like this. Of course, you have to make the cut so you could separate it. Take the other side, the other easy side. So we'll do the cut like this. So you do the cut like this. So you have dot, 2-point G plotted, and of course the cut was like this, so you have to have a cut because you cut it like this all the way this. So you make the dot E, and everything else is dotted, and also all the way to edge, and there's dotted here. Now, this truss after cut, after the section, what is the best point to take so you could find the other? Remember, he need to know DG force, FDG, and he want to find out FH. You can see here from applying the summation of forces of x equal to 0 that there is nothing else in the x-axis except FDG and FFH, which means that FDG should be equal to FFH, but opposite in direction. Same magnitude and opposite direction, because summation of forces of x equal to 0. Now, we don't need to find summation of forces at y equal to 0 because these are the two things that we need, and they are in the x-axis. So what are the other option? Third option is summation of moment. So let's take summation of moment at a place where we could cancel everything. If you take summation of moment at D, which means 0.6 is cancelled, FDG is cancelled, FDE and EF is cancelled. What could we do? What could we get from this summation moment at D? We could see that if there's a nail here, this FH will rotate the whole truss counterclockwise. And what is this distance? Perpendicular distance? That is 9. 4.5, 4.5. So summation moment at D equal to 0. Of course, he did the other one. Let's do that. Summation of D is equal to 0. FH 9, and of course you'll have this is gone because moved, and a nail at this 0.5 will pull the things also the same way counterclockwise. And what is the distance between perpendicular between B and D? It is B and D, it is 6 feet. So 6 feet, 0.5 times 6 feet. And of course the last one, AY at moment at D, AY gonna push it clockwise, and you have to do it from perpendicular distance is 12. So minus AY times 12. Which is, if you take it on the other side, is plus AY times 12. So you rearrange this equation. Remember, you have AY here, or F. So we have AY 1.6 kip. So you could get that FH is equal 1.8 kip tension. Since it's plus, it is tension. We'll leave it tension. Now, what is the next one? Once you find summation of moment at D and you find FH, you could find summation of force at x equal to 0. Remember, this is y, this is y, this is y, this is y, and this is y. The only one that is in the x-axis is FDG. And remember, FFH was positive 1.8 kip. So what will be FDG? It will be 1.8 kip, and it will be compression. The opposite, it can be minus. And you can see it here, it's 1.8 kip. But here he did summation moment. You could do summation force at x equal to 0 and then find the answer. But let's do summation moment at F. Here. This is cancelled, this is cancelled. What else? That's it. So you can see that AY will pull it in the negative 12. AY 12. and FDG counterclockwise, and this is the distance. Times 9 and then 0.5 times 6, you'll end up with FDG is equal minus 1.8 kip, which is the other one that we have before, 1.8 kip compression. Thank you.